Hey there, Applied 30. This is a little bit weird. We're moving on to a video platform. This lesson in particular is going to be extra weird because I'm actually going to be moving on to a document camera for today's lesson. We're actually talking about something called distribution. So we looked at central tendency the other day. We talked about mean, median, mode, range, that kind of stuff. And we also understood that we could draw graphs with that kind of information. Today we're going to continue on with the graphs. We're looking at two different types of distribution, or two different types of graphs. One of them is called a histogram. That's when all the bars are touching each other side by side by side, and it's a lot easier to show that on a document camera. The other one is called a frequency polygon. You're probably more familiar hearing line graph or a midpoint line graph, because that's what it is, a line graph, but it makes a shape, so that's what we call a frequency polygon. Anyways, I'm going to switch over to the document camera. I'm using one that I downloaded online. Maybe not legally. I'm using one that I downloaded online, so I apologize for the watermark, but that's what I'm going to work with. So I'll see you there in just a second. All right, Applied 30. So now we are back onto the document camera over here. I apologize for the watermark up at the top where it says Bandicam. My document reader just wasn't working for some reason, so I had to switch over to this thing. I didn't buy it, so we gotta deal with the watermark. We'll get by that though, I hope. What we're talking about here is frequency distribution, and there's two ways we're looking at that: histograms and line graphs, or line polygons. Now the reason for that is there's actually a third way of navigating through frequency distribution, and that's when we're given a table of data. But when I give you a table of data, like this, it looks overwhelming. Now, just so that you can follow along, this is on page 213 in your textbook. It's talking about the flow rate of a water system, I believe it was the Red River, from 1950 to 1999, and it was measured at the Redwood Bridge. Lots of information here. It is overwhelming. If we had an idea of some intervals, we could probably graph this, and it'd be a lot easier to read. And that's what I'm going to show you how to do. So first, I'm going to highlight a set of data that I've selected to be a part of a decent interval, and you're going to see them highlighted in red over here. And if you count them, so from 1953, 54, 58, 61, 68, 73, 77, 81, 88, 90, and 91. If you count them, there's 11 of them in total, and they fit into my interval, so I'm going to show you a table here that I'm tallying them in. From a flow rate of 150 to 600, there were 11 of them. So let's flash back to that real quick so you can see it. Those are all between 150 and 600 meters cubed per second. Now, ideally, we should have some intervals for all of our data. It should be fairly reasonably spaced apart. So that's what I've done over here. It's about 450 off on each step. And we're just going to do the second one together so that you can see where the numbers come from. So 600 to 1050 meters cubed per second. We should find 9 of them. So I bring up the same graph as before. That's this guy. We should be able to highlight 9 that are between 600 and 1050. And there they are. And by doing that, we can tally up every single number on our table for the frequencies. So now I have enough information to make a graph. The frequency is my vertical axis, my y-axis, it's going up and down, and my flow rate is going to be on my x-axis. And when I set it all up, put it together, it's going to look kind of like this. I've even put a title on my graph. If you make any type of diagram, you should always title it. It's the same thing as unit, so if you don't have a title, then there goes off a mark. So make sure you have that. So this is my graph, and essentially I go to each of my intervals. I'm going to flip back to my table for a second over here, and I'm going to look at the 150 to 600 right at the top here. So from 150 to 600, we should go as high as 11 years under frequency. So on our graph, we should be somewhere around up over here between the 10 and the 12. I don't know if you can actually see my mouse on Bandicam, but I'm looking between the 10 and the 12. So I'm going to move a polygon out of the way so you can see. And oops, let's shift back into frame here. There we go. But as you can see, we are at 11, and unlike a bar graph where the midpoint of your bar graph lines up with your data, we're looking at an interval. So between 150 and 600, we have this blue bar that goes all the way up to 11. And between 600 and 1050, we have a line that goes all the way up to 9. And I've done that for every single one of my data points. And this picture is a lot easier to read than that data set I gave you before, right? You can immediately tell me, well, most frequently you're getting between 1500 and 1950 meters cubed per second. You can tell me least frequently you're getting something between, oh, this should be 3000, I'll make that fix, between 3000 and 3750. Okay, and you can also see that, yeah, we get some floods quite frequently here in the Winnipeg area around the Red River. About 9 times you're going to get more than 4,200 meters cubed per second. So good information there. Now another way of looking at this data is we could see a line diagram. Let's look back over here for a second. So this is our same chart as before that we tabled. So we tabled the number of years, flow rate that was given to us. Those are the intervals we came up with. But to make a line graph, you need to have a midpoint from your intervals. So that's what this middle column is going to be. And just to show you how we do the math for the first one, we're taking our first two numbers, we're going to add them together. So 150 and 600, that gives us 750, divided by 2, which means our midpoint should be 375. Now if I do all the math to get you caught up, boom. Those are all the midpoints. So you should be able to come up with something like that. For a line polygon or a line graph, it looks kind of like this. I'm going to show it to you in 2 pieces. We plot our midpoints on the x-axis on the bottom. Our number of years doesn't change. But now we are actually traveling to the middle of each of our data points. And we're just putting dots and then connecting the dots with a line, hence line diagram. Once we have all of our information, we add more and more and more of those dots, as you can see over here. Like so. Let me just go on to another slide where it's a little easier to read. There we go. So you can see all of our dots on our polygon here. And the polygon is just a shape that this makes compared to the graph. Okay, so that's what our line graph or our line polygon looks like, and now you know what a histogram looks like as well. So we should get some practice in on that. It's going to be on page 221, and I don't remember what pages I assigned, so when I edit, I will put those in on the edit. If you have any questions, feel free to email me. Right now it's a little bit swampy with all the editing and whatnot, but by all means, if you have a question, let me know and I'll get to you as soon as I possibly can. All right, thank you.